Hello students, welcome to Math Online Academy by Sandhya, myself Sandhya. Today topic is Chapter 1, Real Numbers, Example 5. Using example 5 and 6, you can solve exercise 1.3 total. Today I will explain the example 5. So what is the question? Using the above theorems. Above theorems means we solved 1.3 theorem, 1.4 and 1.5. Based on rational numbers, terminating decimals or non-terminating decimals, what is the condition of terminating and non-terminating. So using above theorems without actual division. State whether decimal form of the following rational numbers are terminating or non-terminating, repeating decimals. First of all, already we discussed. Briefly, let's see what are terminating. Here, let's see here. What are terminating decimals? Terminating decimals and non-terminating decimals. So, based on the denominator. In the form of P by Q na rational number, based on the denominator form, we can say directly this is the terminating, this is the non-terminating. What is the form? 2 power n 5 power m. If Q equal to 2 power n 5 power m, that is terminating. If in the form of P by Q, Q not equal to in the form of 2 power n and 5 power m. These are non-terminating repeating decimals. If you check the Q is in the form of this is terminating. If Q is not in the form of 2 power n and 5 power m, that is non-terminating. So, let's we directly check what is the condition of Q. So, here without actual division. We didn't do the actual division. Directly based on the Q form, we say that is terminating or non-terminating. So, first one is 16 by 125. So, what is the Q value here? Q value is 125. Okay. For 125, you do factorization. 125 factorization. What? 5 2s are 5 5s are. And again 5 5s are. So you can write 125 equal to 5 into 5 into 5. Means 5 cube. Yes? 5 cube. And into we can write na 2 power 0. So, this is in the form of 2 power 0 into 5 power 3. This is in the form of 2 power n and 5 power m. M comma n are non-negative integer. So, this is which form? Terminating decimals. So, 6 by 125 is a terminating decimals. So, 16 by 125 is terminating decimals. In shortcut, you can write directly. This is the long one now. Directly 16 by 5 into 5 into 5. So, 16 by 5 cube. 16 by 5 cube means 16 by 2 power 0 5 cube. This is in the form of 2 power n and 5 power n. So, this is terminating decimals. terminating decimals. And again, next one. 25 by 32. 32 forms 2 ones are 2 sixes are, and again 2 eights are, and again 2 fours are, and again 2 twos are. How many times? 1, 2, 3, 4, 5. 5 times. So you can write 2 power 5. 2 power 5 means 25 by 2 power 5 into 5 power 0. So this is again terminating decimals. Terminating decimals. Next one is 100 by 81. 100 by 81 means 81 in fractions. 3 2s are 6, 3 7s are 21, and 3 9s are, and 3 3s. How many times? 3 power 4 times. So equal to 100 by 3 power 4. So this is not in the form of, that implies 3 power 4, not in the form of 2 power 0 and 2 power n and 5 power m. So this is non-terminating decimals. Non-terminating decimals. Okay, this is non-terminating decimals. Here we are checking only Q form. What is the form of Q? Whether it is 2 power n or 2 power n and n power m. Is it that is in the form of 2 power n or 5 power n? 41 by 75 na? 5 ones are 5 5s, yes, and 5 3s. Okay, directly 5 square into 3. Here also what? This is also not in the form of 5 square into 3. It is not in the form of 2 power n and 5 power m. So this is what? Non-terminating decimals. Non-terminating decimals. So based on the above theorems, without actual division, we can say what is decimal, what is terminating decimals, or what are non-terminating numbers. Okay. Here we check the only Q is in the form of 2 power n, 5 power n. Is it in the form of that or not? By using that only, that is terminating or non-terminating. Okay. In the example, this is example 5, and the next one is example 6. Using this example 5 and 6, you can solve exercise 1.3 total. Okay. Next one is example 6. What is example 6? And next example is example 6. Write the decimal form of the following rational numbers without actual division. So, by using before theorems without actual division, we can solve the all rational numbers. So, first one is what? First one is 35 by 50. So, without actual division, you write the decimal form. So here you do 35 5 sevens. Yes, for 50 5 ones 5 tens, and again 5 twos. So here for 35 you can write 5 into 7. For 50 5 into 5 2 times na. So 5 into 5 into 2. Okay, you can cancel 5 5. So final one is 7 by 10. 7 by 10 means you can write in decimal forms 0.7. If you remove the point, again here comes 0. So 0.5. This is the decimal form of the rational number 35 by 50. Next question is 21 by 25. Again for 21, see 3 sevens, and for 25 you write 5 5s. Yes, 3 into 7, and here 7 into 5. Okay, sorry, 5 into 5 na, sorry 5 into 5. So 3 into 7 and 5 square. For 5 square, here q form is in the form of 2 power n or 5 power n. So for this you can 2 power 2 and 2 power 2. You multiply and divide with 2 power 2 and 2 power 2. Okay, why we are using only 2 power 2 means, if you for simplifying it is easy. Here 5 power 2 na, let's see why we use only 2 power 2. Finally it will become 3 into 7 into 4 divided by 5 into 2. You can write 5 into 2 whole square. Yes, and here multiply. So there is 21 into 4. 21 into 4 means 21 4. 4 ones are 4, 4 twos are 8. 84 by 10 square. Okay, 10 square means 100. So 84 by 100. 84 by 100 means you can write 0.84 in decimal forms. If you remove the point, you can get in denominator 100. So 84 by 100 means 0.84. Why here we use 2 square means, but by simplifying we use here 2 square. Next question, let's say. Next one is 7 by 8. For 7 by 8, 7 by, for 2, 8, 2 4s in factorization. Okay, 2 is in how many times? 3 times. So you can write 2q. In this we are simplifying and we are converting into decimal forms. Here 2q. For example, if in the form of q is 2 power n and 5 power n. If we use here 5, it will become 10. 5 into 2, 10. That is easy to convert in decimals. So 7 by 2 cube, 5 cube and 5 cube. If you multiply with and divide with 5 cube, 5 cube cancel, it will come 1. Why we are using only 5 cube means here already 2 cube. If you use 5 cube na, it will become, see, 7 into 5 cube means 125. And for simplifying, you write 2 into 5 whole cube. It is easy to write the whole cube, both. So 7 5 is 35, 3 is 14, 7 to the 14, 14 into 3, 17, 17 1, so 875. Here total is 875. This is the 10. For this purpose only we are using here 5 cube. You can take whole cube is common and 5 to become 10 for simplifying. So 875 by 1000. By 1000 means 0.7875. If you remove the here decimal point, you can get in denominator 1000 again. So 0.875. These are the decimal forms of this rational numbers without actual division. We are converting into factorization by in the form of 2 power n, 5 power n. So these are the decimal forms. By using these methods, you can solve exercise 1.3. Okay. If you like this video, please share and subscribe. Thank you.